use in trigonometry. So let's start with some vocabulary. Right here, I've got initial side of an angle, terminal side, and standard position. If we're going to start talking angles, and we are, we need to know what those three things are. So if I go and I draw, let's try to match my angle, the initial side of our angles are always going to be right here on this positive x-axis. Now, if we have a positive angle, we're going to rotate. This is kind of weird. We're going to rotate counterclockwise. Squeeze it. Yes. So we're going to rotate from this initial angle where we start, initial means where we start, counterclockwise, and that's going to give us a positive angle measure. Where we stop, that is, I always think of like terminals for trains or buses or airports. The terminal side is where you stop. So we have our initial side in standard position right here is always going to be on the positive x-axis. We're going to rotate counterclockwise to get a positive angle. The angle where we are, the ray where we end is our terminal side or our terminal ray. If we have a negative angle, let's change colors. If I'm going to do a negative rotation, then I'm still going to start in my standard position. Purple and red, that's kind of weird. There's my standard initial angle, and then the negative rotation, I'm going to go this direction. So if I drew this angle right here that started on the positive x-axis and ended on the negative y-axis, then I would say that this has a negative 90-degree angle. All right. Now, if I ask you to draw these three angles in standard position, you're going to start. Now, these don't have to be perfect, folks. Just give me a quick version of a set of axes. We're going to start standard position. Here's our keyword here, standard position. We're going to put our starting ray on the positive x-axis. And we're going to rotate, since we have a positive 240 degrees, I'm going to start rotating counterclockwise. There's 90. Got to keep going. There's 180. 180 to get me to 240, I'm going to need, what, 60 degrees more? So I'm going to rotate up to about here, and I'm going to draw in my ray, and then on my diagram, I'm going to write 240 degrees. If I want to go 500 degrees, well, we know, you guys know from your stunts and things, that if you spin a full circle, that's 360 degrees. This 500 degrees is more than 360, so I know I'm going to go at least one full circle. So I can start with that if my initial ray is right here on the x-axis. I'm going to go one full circle, and then the question is how much farther. So all I'm going to do to figure out how much farther is I'm going to subtract my 360 from my 500, because 360 is the full circle I've already done. And I'm going to get 140 degrees more. So let's switch the pencil. So to get this extra 140 degrees from where I ended my first circle, there's 90. 180 would put me over here. I don't want to go 180. I want to go 40 degrees less than that. So I'm going to draw in my terminal ray right about there. It doesn't have to be exact, because we're going to cover ourselves by writing right on our little diagram my 500 degrees. I do need you, when you do these, to make sure that this terminal ray is in the correct quadrant. Just real quick, let's go back up here. Remember when we do quadrants, just in case you don't remember this, it goes quadrant 1 up here on the top right side. We rotate counterclockwise. Quadrant 2 is in the top left. Quadrant 3 is in the bottom left. And quadrant 4 is in the bottom right. All right, so now if I want to go on to this example C, see my cute little star I put on it right here. This one's special. I did that because, not because you guys need it, but because I need it. I get anxious and sometimes I forget to teach this negative thing. So I'm going to cover it extra good for you today. Well, let's go to a better color. If I want to draw a negative 50-degree angle, I'm going to start with my set of axes. Standard position puts me on the positive x-axis to start. Negative rotation means I'm going to go clockwise. The question is, do I stay in that quadrant or do I pass this vertical line here? 50 degrees is less than 90 because I know down here, if I went clear over to this negative y-axis, that would be a negative 90-degree angle. So I'm going to stop before I get there, and then I'm going to write negative 50 degrees right inside my angle there. So the next thing you're going to see in this section is finding coterminal angles. Coterminal, break the words down. Co just means with. Just, I think of my Spanish. I don't know a lot of Spanish, but I know co means with in Spanish. And then the terminal side, we just learned that the terminal side, right here, so in our coterminal, ooh, that's kind of ugly. In our coterminal, terminal is our ending ray, or the ending side of our triangle. So coterminal angles are angles that start at the same place and end at the same place. Now, initially you're probably thinking, well, that's dumb, Pekka, because that's the ray that the angle we just drew. But we can take an angle, let's say this negative 45-degree angle. So let's use what we just learned. Set of axes. Negative 45 degrees means go counterclockwise. I'm going to start on my positive x-axis. I'm going to rotate clockwise 45 degrees. This is a negative 45-degree angle. Well, now, are there any other angles that I could rotate through and end starting at the positive axis and still end right here at that terminal ray? And yeah, there's lots of them. I could rotate clockwise, go right past, come all the way around, and then stop. So I'm going to do a full circle plus that 45 degrees that I already went in the negative direction. So I'm going to make this whole thing negative. Well, we know a full circle is 360 degrees plus another 45 is going to put me on what? 360, 45. It's okay to leave these doodles on your paper. I'm going to be at 405. So one of my coterminal angles, my negative version, is going to be negative 405 degrees. I could rotate the other direction. Let's change our pencil color. Let's say, let's rotate counterclockwise. I could start on my positive x-axis, and I could rotate counterclockwise. Now that time I did not go a full circle. So if I didn't go a full circle here, the question I ask myself is, well, how much shy am I of going a full circle? Well, we know that right here because we know that this angle that we're working on is that negative 45 degrees. So if I want to find my positive coterminal angle, I'm going to just, kind of don't have enough space here. I'm going to take my 360 degrees and subtract that 45 that I didn't use. And we can do a little borrowing up here. And I know that my positive coterminal angle is 315 degrees. Now I could have added another full circle instead of just adding one full circle. I could have added 360 again. There's lots of fun things you can do with this. So right here I could have added 360 again and gotten another coterminal angle, or I could have kept subtracting from 360. So there's lots and lots of coterminal angles. The trick is right here. When you're finding coterminal angles, you're either going to add a full circle or subtract a full circle. If we're working in degrees, a full circle is 360 degrees. So we're either going to add 360 degrees or we're going to subtract 360 degrees. So if I go over to this 395-degree angle, my part B over here, And I want a coterminal angle. Let's read the question, make sure we're doing this. Yeah, we're just going to find a coterminal angle. I'm going to take my 395 degrees that I'm giving, 395 degrees. I'm going to subtract 360 degrees. That's going to give me my 35 degrees. That's a positive angle. Or I could take my 395 degrees and I could add 360 degrees. That would be another coterminal angle. So if I add, I'm going to have a 755 degree angle. So the trick again, and remember that's either add a full circle or subtract a full circle. In degrees, we're going to be either adding or subtracting 360 degrees. This is used, I wrote this over here. This is used when we're looking for easier numbers to work with. If I had a choice between using a 755 degree angle or a 395 degree angle or a 35 degree angle when I start working on some of my trig equations or when you start working on some of yours, I'm thinking this 35 degrees is a whole lot nicer number to work on. And if it's going to give me the same answer, I might as well use the simpler number. Or the other thing that can happen, this is still a little ways off for you guys, but the other thing that can happen is sometimes when we start solving trig equations, there's more than one answer, and these coterminal angles are what are causing multiple answers. Okay, I kind of jumped the gun when I was talking positive and negative on the last example. So if I want to find a positive or a negative coterminal angle in these next problems here, I want a positive and a negative this time. The last one just said find a coterminal angle. This one is asking for two coterminal angles. The trick here is we're going to add 360, or we're going to subtract 360 because we're working in degrees, and we're just going to keep doing that until we get a different positive angle and a different negative angle. If I take my 230 degree angle that I'm given here and I add 360, that's going to be a positive number, so that's going to be my positive coterminal angle. So my positive coterminal angle would be 590 degrees. If I take the 230 that they give me and I subtract 360, that's going to be a negative number, but I don't like to subtract like that, so I'm going to go 360 on top minus the 230, and I'm going to get a 130, but my 360 is negative, so my negative coterminal angle is going to be a negative 130. So add or subtract 360 until you get a positive and a negative. When we jump over to number 7 over here, this is number 7, by the way, that's the example right in your textbook if you're working out of your textbook. I have a 740 degree angle. I'm going to subtract 360. And that's going to need to do some borrowing. So I have a 380 degrees. That's a positive number. So there's a positive coterminal angle. I'm going to take that 380 and I'm going to subtract 360 degrees more. That's going to give me another coterminal angle, which is going to be what, 20 degrees. So there's two positive coterminal angles. But my question up here said find a positive, which we have two now, and a negative. So I'm going to keep going because I want to keep going until I get a negative coterminal angle. So I'm going to take my 20 degrees and I'm going to subtract 360, but that's just weird set up like that. I'm going to convert it. I'm going to put my big number on top, subtract my 20. It's going to give me 340, but the 360 was a negative, so I'm going to make that a negative. So now I have, and I'm grading this, it didn't say find the smallest possible positive or negative. So if you gave me 380 and negative 340, I would have to give you credit. Now, in Big Ideas Online, I'm not sure, they might specify find the smallest positive and negative. In that case, if they said find the smallest, you're going to type in the 20 and then negative 340. All right, one more. Let's go new pencil. Try. Now I have this negative 135 degrees. It's different, but it's still the same technique. We're going to either add 360 or subtract 360 repeatedly until we get a positive and a negative. We start with a negative. If I have a negative 135 and I add 360, that's just a weird setup right there. So I'm going to switch it over. I'm going to go 360 minus our 135. And I've got a 225-degree angle. Now, if you can do that in your head, great. If not, I'm just showing you what it would look like on paper. And all of this extra work that I'm leaving on here, all of this work, this is beautiful math. Leave it on your papers, guys. Don't start erasing. So it said in the directions, find a positive and a negative. We have a positive. If I keep adding 360 to that, that's going to get bigger positive. So adding 360 is not going to be useful to me anymore. So I'm going to go back. I'm going to take my original 135 and then I'm going to subtract 360 because our choices are add or subtract 360. Those are